Alright, so I think I'm recording. Let's take a look at some of our increasing, decreasing functions from Scale 2A. Alright, well, there it is. A function is increasing if as x increases, y also increases. A function is decreasing if as x increases, y is decreasing. And a function is constant if as x increases, y remains constant. So let's take a look and see where we can determine where this function is increasing. We describe the location of where it's increasing using x-coordinates and writing that in interval notation. So here is a minimum point. That's kind of thick. Here is a minimum point. The coordinates of that point is 2, -4. But as far as the location is concerned, in my answer for interval notation, I'm interested in the x-coordinate. Now you can see if you pick different x's here that from 2 to 3, x increased, and from the y-coordinate is now 3, and -4 increased to 3. So in this portion of the curve that I'll highlight in yellow, as x increases, y increases. And that continues off of the graph, so we are to assume that that pattern that they've illustrated will continue on forever. So, like I say, pick any 2 points in the region that I have shaded, and as x increases, as you move to the right, you'll have to also be moving up to stay on the graph. So that looks pretty familiar probably to you with rise over run and your studies from Algebra 1. So you can kind of relate it to where it's increasing, decreasing, or constant as the slope between the 2 points. So now that's not the only place on this graph that it's increasing. It's also increasing from this point up to this point, from that min to that max. We can see that it's increasing there. That if you pick any 2 points in the region that I've shaded, that as x increases, y will also increase. So when we have 2 different intervals, we'll use a symbol that is called the union, and it looks like that, just a big U, and we can think of it when we read it, when we try to determine the definition, why we can think of it as the word or. You're in this interval, or you're in this interval. This interval union this interval. So let's describe the interval here on the left using the x-coordinates. The coordinates of this point is -2, -4, but I am interested in the x-coordinate. Here at the origin, 0, 0, and I'm interested in the x-coordinate. So describe this region that's in yellow there on the left. It's from -2 to 0. Then, or, we're in this interval, so I have to have a union, and the x-coordinate here is 2. There is no endpoint like there was in the first, where we're hitting the arrow, and that arrow is indicating that you're going up, but at the same time going to the right. The x-coordinates are left and right. I'm interested in the fact that it's going to the right, so I use the symbol infinity. So this is where the function is increasing. Alright, so let's go ahead and highlight it in green where it's decreasing. So in this region, as I move to the right, I'm going down. If you pick any 2 points in that region, as x increases to stay on the graph, y has to decrease. You have to go down. Alright, that's not the only place. Also from this maximum to this minimum. So again, we always, when you're writing interval notation, it's always a smaller number, comma, a larger number. As we come in from the left, as we're moving left to right along the graph, first thing we hit here is the arrow. That arrow is actually telling us two things. You're going up to infinity, but the x-coordinates are heading towards negative infinity. So when I come at it from the left, I'm coming at it from when it's negative infinity, then all the way to this -2, the x-coordinate of that point. Then, since there's a jump, since there's a break in the shaded region, I have a union symbol. The x-coordinate at the origin is 0, and the x-coordinate here at this minimum point is 2. So there's where it's for as far as this graph is concerned, it's never constant. So nowhere or never. Don't leave it blank, but indicate. Some people will use the symbol for the empty set, and that's fine as well. Alright, so that's problem number 2. Let's go problem number 1. Let's go ahead and do problem 2, and I'll do two problems per video here. So it's kind of the same idea here with number 2. It's a similar type of graph. Now, on this one, in recent years, the software and stuff to produce computer-generated graphs is always getting better, and we're able to put these arrows on the end in these graphs. Now you can see in the first one there wasn't arrows there. I drew arrows on there, but you can see that it's going off of the graph. So the students and readers of the graph always had to know that pattern continued on forever, and they had to just visualize the arrows or write them on there themselves. Well, now the computer graphics can go ahead and put the arrows there if needed. So let's keep the same colors. Let's keep yellow for increasing, green for decreasing. So as I move across the graph from left to right, I'm decreasing here. As I'm moving to the right, I'm going down. Back in Algebra 1, if you pick 2 points and determine the slope would be negative. Then I hit this minimum point, and it changes, because then the graph starts to go up. The y values begin to increase. As x increases, y is also increasing. So then we hit the top, and now we're going down again. So it's a roller coaster, right? You're going down, come down to this minimum, and it changes again, and it goes up, and it continues going up because we go through that arrow. So these arrows at the end of the graph are indicating two things: information about x and information about y. The information about y is that the y values are increasing. The information about x is the x values are decreasing. This arrow is giving us two pieces of information. If we break it down into single pieces of information, as you're moving up, you're also moving to the right. Moving to the right, the x values are heading towards positive infinity. Moving up, the y values are heading towards positive infinity. Alright, so if we're looking at where the graph is increasing, that's highlighted in yellow. So we're interested in the x-coordinates of these points. So here, the coordinates of the point is -2, -5. And the temptation for some students is to get confused and accidentally give the -5. We need, for the interval notation, to always use the x-coordinates. And it's always a smaller value. Negative infinity is as small as it gets, comma, a larger value. Now we have a break where it's increasing. We get to this point that has coordinates 2, 5, And again, we just want to use the x coordinate, so we have union 2. I said increase. Well, I've done that wrong. Hey, here's an example of how not to do the problem. Pay attention to your color schemes and to where it's increasing and decreasing. I just started to shade it on the left to right, so I started on the left and I started to write increasing. Well, as we said before, this is decreasing, so you're probably yelling at the screen, what is he doing? Let's try this again. My function is increasing. As x increases, y also increases. That's happening here. X is increasing, y is increasing. That is happening where I have shaded in yellow. Alright, so the first interval here is going from x equals -2 to x equals +2. From x equals -2 to x equals +2. See, another thing, interval notation is not a single point on the graph. It's describing an interval, a range of values for x. I don't like to use range when I'm talking about x because later range is always associated with y. So let's just say an interval of value, a collection of values, and they're all x values. Union, I need the x coordinate at this point, which is 6. I ignore. It's not that I'm ignoring the y coordinates. The y coordinates is what's actually increasing the output of the function. The x values tells us left and right from the origin where you have the location where things are going on. So from 6 all the way to infinity. That's where it's increasing. Sorry about that before. I definitely did not intend to confuse anybody. The decreasing, where it's green, I've hit this arrow, and remember the x coordinate of the arrow that coming from the left here, negative infinity all the way to the x coordinate of -2. Any two values, any 2 points in that interval, as x increases, y is going to be decreasing. Or if we're in the interval from +2 to +6, same thing happens. Pick any 2 points that are in that region. As x increases, y decreases. Alright, and where it's constant, well, nowhere. It's never constant. So if you'd like, you can just use the symbol for the empty set. Alright, so I hope that helps. I'm going to stop this video and do these problems in pairs. And so, sorry about the mistake.